Okay, 4.5. Okay, we did 4.1 through 4.4 on the last thing. It says an engine uses 6 gallons of gas when it runs for 7.5 hours. If it runs at the same speed, how many gallons will be used in 10 hours? Now, these are going to seem kind of simple to start with, okay? On that sheet, you're going to write gallons and hours. Those are the two units. If the number of gallons the engine uses go up, well, then it can run for more time. That's a direct proportion. We align those old school. Put GH, GH. Okay. So 6 gallons, 7.5 hours, and then 10 hours. Cross multiply and divide, you get 8 gallons. Okay, next problem. In excavating the foundation of a building to a 4-foot depth, 1,800 cubic yards of soil are removed. How many cubic yards are removed when excavating a 9-foot depth? Round to the first decimal place. Okay. You got foot and cubic yards, so feet, cubic yards. Now, if the depth of the feet go up, then the number of cubic yards I have to remove goes up. Okay, that's how excavation works. So that's, again, direct. So I'm lining that up old school. Don't get too cocky though here. 4 foot is 1,800 cubic yards, and then we know we have 9 foot. Cross multiply and divide, you get 4,050 cubic yards. I don't think you had to round that. I think it comes out evenly. Yep. Okay, next problem. A homeowner pays $2,973 in taxes on property assessed at $187,200. After improvements are made, the property is assessed at $226,700. Using the same tax rate, how much tax will be paid? So you got taxes and property. Now, if your taxes went up, that's because the value of your property went up. That's how taxes work. You got to use a little bit of street smarts, okay? So taxes, property. Taxes, property. So they told me that this guy had to pay $2,973 in taxes when the property value, his property value is $187,200. Now he makes the improvements. Now his property is at $226,700. Now we cross multiply and divide, and that's $3,600.32. I don't care if you put the cents. I really don't. So far, yeah, wow, it's just proportions. Well, that's going to change after this next page. The tank shown contained 7,200 liters of water when completely full. How many liters of water does it contain when filled to a height of 3.4 meters? So there's the tank. It's got liters and meters. Now, as the liters of water increase, well, then the height of the tank would need to increase. Okay, so that's, again, direct. So far it's kind of ho-hum. Now you gotta get a look at the picture. The tank shown, so the tank's shown 6 meters. When it's filled up, it carries 7,200 liters of water. Well, what happens if we only fill it up to 3.4 meters? Cross multiply and divide, you get 4,080. So it wouldn't have as many liters because it's not as high up. Okay, a crankshaft speed of a car is 2,915 revolutions per minute when the car is traveling 55.75 miles per hour. What's the crankshaft speed when the car is traveling 42.5 miles an hour? So you got revolutions per minute and miles per hour. Revolutions per minute is how many times the wheels turn on a car. They're what drives the speed, okay? The faster they can turn every minute, the more they can get around every minute, the speed goes up. So that's direct. Okay. Okay, so again, RMMPH. RMMPH. Okay, so we know that 2,915 revolutions per minute make a speed of 55.75. What if the speed's only 42.5? Well, then there's going to be less revolutions per minute, okay? So I cross multiply and divide, I get 2,222. Okay, and the last one, this is the last problem for the gravy train. Two forgings are made of the same stainless steel alloy. A forging that weighs 170 pounds contains 0.80 pounds of chromium. How many pounds of chromium does a second forging contain if it weighs 255 pounds? So you got pounds and pounds of chromium. Just call it overall pounds and pounds of chromium. So if the overall pounds of the alloy go up, well then the pounds of the chromium go up. Okay, so again, that's direct. So you can just put pounds and then POC, pounds of chromium. So I know that if it weighed 170 pounds, 0.80 pounds of chromium. Well, guess what? Now it's up to 255 pounds, so it's probably going to be more pounds of chromium than it is. It's 1.2. Now the game changes, okay? 6 bakers take 7 hours to produce the daily bread requirements of a bakery. Working at the same rate, how many bakers are required to produce the same quantity of bread in 5.5 hours? You gotta think here. Otherwise you're gonna get an answer that makes no sense. Nobody's ever seen one like this before. All the problems I've done in algebra are directly proportional, okay? This is going to be different. You're going to learn something new. As the number of bakers go up, that means increase. What happens to the time it takes to bake the product? Well, I think it takes less time. The more help you have, the less time it takes. So that's inverse. This is how you set up an inverse, okay? First off, you will not be doing B and H on the same line. You are going to do BB, HH. The labels must align like that. Now here's what you're going to do. We're going to call this Baker's 1 and Hours 1 because they go together. Bakers put a subscript. Then this 5.5 hours we're going to call Hours 2. Now, first off, we set them up like that. Secondly, it's B1, H1. That's why it's called inverse. They're inverted. They do not line horizontally. They line inverse. B1's on top, H1's on bottom. Okay? So H2, B2. Okay, so Baker's 1 would be 6. Hours 1 would be 7. Okay? B1, B2, H2, H1, you flip it, okay? And then 5.5 hours is H2, but I do not know B2. Now I cross multiply and divide that, and I get an answer of 8. Now if you read it, it makes sense, okay? When we got done in 7 hours, it took 6 bakers. Well, the next time, if I only want it to take 5.5 hours, I better hire more bakers, okay? 8. So again, you put subscripts on your labels. They're in the same sentence, B1, H1, and then later on H2. We don't have the B2. That's the answer to the problem, 8 bakers. When you line them, again, let me replay that. BBHH has to be that way, okay? Then B1, H1, H2, B2, they go diagonally, okay? So you get B1 was 6, H1 was 7, so those are aligned across. It's really the only way you get an answer that makes sense. Okay, now the next problem. A balanced lever is shown. there's a balance lever. Observe the heavier weight is closer to the fulcrum than is a lighter weight. Okay. An increase in the distance from the fulcrum produces a decrease in weight required to balance the lever. Determine the values. It says flat there. Increase, decrease. That's inverse. So we're going to put W1, W2, but then we have to invert it with the D's. It'd be D2, D1. And then I just solve away on this table. I got 2 rows to figure out. Okay, so W1 we don't have. W2's 3, W2 or W1 76.8, my bad. W2 24. Now D2 we don't have, D1's 35. Okay. Cross multiply and divide and you get 112. Now let's check our answer. W1's more than W2. The force of the weight of W1's greater than W2. Okay. Well, the reason that is because the distance is less than it is on D2. W1 more than W2. Then D1 has to be less than D2. Okay, then in the next one, okay, W1 don't have it. I have 3/4 of a pound for W2. D2 112, 35. So you cross multiply and divide, and you come up with an answer of 7.5. Remember, increase in the bigger weight means shorter distance. Smaller weight means greater distance. It says so right there. That's why it's WWDD1122. Okay, and then the last problem. Of the 2 gears that mesh is shown, there's the 2 gears. The one that has a greater number of teeth is called the gear. The one that has a fewer teeth is called the pinion. For the table, determine the missing value in each problem. Now, you need to underline teeth and revolutions per minute. Okay? Now, I write that off to the side. Alright, now as the number of teeth we have to go through goes up, I'm not going to get around that as fast in every minute. So the number of revolutions I make in the minute go down. Okay? See, this one has more teeth, but it's going to take him longer to go around than this guy. So he can do more revolutions per minute because he has less teeth. More, less. Inverse. Okay? Now, here's how you want to align that. So you're going to put teeth and teeth, revolutions per minute, revolutions per minute. But you're not going to go 1, 1, 2, 2. That's not going to make any sense. Okay? We're going to put gear, gear, so teeth on the gear, revolutions per minute on the gear, like I would 1, 1, and then pinion, pinion. Okay? Now let's roll. 48 teeth on the gear, 20 on the pinion. 120 revolutions per minute on the gear, and then I cross multiply and divide. I come up with 288. Okay, next one. Teeth, teeth, RM, RM. But 1, 1, 2, 2 is not going to make a whole lot of sense here, okay? Because you got gear and pinion. So teeth on gear, revolutions per minute on gear. Remember, we're aligning them diagonal because they're inverse. Goes up, goes down. Pinion, pinion. Okay. Now, let's go back to our first answer. Remember, the more teeth, okay, gear has more teeth, so it has less revolutions per minute. Pinion has less teeth, so he can get around more times in a minute. Okay, makes sense. Okay, so 32, 24. And then 210 on the pinion. So I'm finding the gear. So 24 times 210 divided by 32 gives me approximately 158. You have to round. Now look at your answers, make sure they make sense. We said the more teeth on the gear, the less revolutions per minute. The less teeth on the pinion, so that the pinion has more revolutions per minute. Okay, teeth. Remember, I'm aligning at this, not TRM. That's how you do a direct. TT, RM, RM. But we don't want to go 1, 1 because you won't be able to figure that out. So teeth on the gear, revolutions per minute on the gear. Pinion, pinion. Okay. So 54 on the gear, teeth, 28 on the pinion. Okay, 80 is the revolutions per minute on the gear, and I have to find the pinion myself. Cross multiply and divide, it's 154. Okay. Now let's make sure we got this right here. Remember, we said more teeth, less revolutions per minute. So here's the gear. Well, the gear's got more teeth, so it's got less revolutions per minute. Pinion has less teeth, so it can get around more times in a minute. Okay. So remember, in the first part, the direct ones are just old school. Okay, old school algebra, but the inverse ones we got to do different. Like Baker's and ours, I go BBHH, 1, 1, 2, 2. Okay, then label them in the sentence B1H1, and then later on you had H2, you didn't have B2. Okay, it's got to be aligned like that. B1, B1H1, H2, B2 on an inverse proportion. Unless, of course, you're doing the gear pinion problem, teeth, teeth, gear, gear, pinion, pinion. That's why it's called inverse. Okay.